Welcome. Today we are going to look at solving absolute value equations using good old algebra. So, just a refresher here. We said yesterday, right, that you could have one solution, you could have two, you could perhaps have none. All right, and so that was from looking at graphically what was going on here. So, let's recall that an absolute value equation is an equation that contains, well, you guessed it, at least one absolute value expression, right? I'm often saying in my classes that we aren't creative in math when we name things. We tell it like it is. So, absolute value equation contains absolute value. Now, to solve these equations algebraically, we have to get rid of that pesky absolute value symbol somehow. And so we can't just pretend those bars aren't there. So what we do is we set up what are called two related equations. And the reason we have to do that is because that expression inside the absolute value symbol, right, it could have been positive, but it also could have been negative, and we don't know because the absolute value, right, is telling us the distance. So what it's equal to is always positive again. All right, so steps for solving an equation here. Oh my goodness, that's embarrassing. I just found a typo. Don't worry, my copy I give you is going to be flawless. So steps for solving an absolute value equation. All right, so first thing we're going to do is isolate the absolute value expression if necessary. Then we're going to set up our related equations. They're going to be two equations, very similar, but we have to deal with that. What if the expression were negative? Then we're going to solve both equations using good old inverse operations. Like we did earlier in the year. And we're going to check our solutions. Beware of what are called extraneous solutions. So extraneous solutions basically means looks like it works, like we did all our work correctly and we get it like it should be a solution, but when we plug it back in, it doesn't work. We get a false statement, right? So something like -3 equals +3. That's no good. And we'll see one of those later on. All right, so first things first, I'm going to solve this one here. So that step one is to isolate the absolute value expression. There's nothing else going on. It's the absolute value expression, nothing else. So we're good to go there. And we can jump to step two, which is set up our related equations. So the first one is just going to be x minus 2 equals 3. Just exactly like what we have before, except we don't want to have the absolute value bars. Now this second one is going to look like this. We're going to have x minus 2 equals -3. And the reason that we make the 3 negative is because it's easier to negate than the x minus 2, right? So if we wanted to negate the expression that's in here, which might make more sense a little bit to you at first conceptually. It's more work, right? Because you have to distribute the negative more places where people could mess things up. So usually it's just easier to negate the right-hand side. It has the same effect. All right, so now that we've set up our equations, we're going to step 3, solve them. So these are just one-step equations. So we're going to add 2 to both sides. And over here, I'll get 5. And over here, I'll get negative 1. All right, so just to revisit, right, step 1 we kind of already did. It was already isolated. Step 2 was right here. We set up our related equations. Step 3, we just solved them. And step 4 is we're going to check our work. All right, so what that looks like is I'm just going to rewrite the problem twice. I like to put a little question mark over my equal sign because I don't know. Did it work? I hope so, but we don't know quite yet. So what I'm going to do is I'm going to take 5 and plug it in to one of them for x, and I'm going to plug negative 1 into the other to check our work. So over here, negative 5 minus 2 is going to be 3. So the absolute value of 3 on the left-hand side. And you know what? That is equal to 3. So that means that 5 works as the solution. Now over here, we'll get negative 3. And you know what? The absolute value of that is 3 as well. So good news, they both work. And you can box them up separately or together, whatever floats your boat. All right, so example 2, we are going to go ahead and solve this guy here. First thing though, we got to isolate the absolute value. So we can subtract 1 from both sides. So I got the absolute value of x is equal to 3. All right, so really 2 and 3 are going to kind of go together here because when I go to set up the absolute or the related equations, they're already solved for here, right? So x could have been 3, could have been negative 3. All right, so then we will check our work. Really, the point of this example is to get you to isolate this guy. All right, so now we're checking our work. Absolute value plus 1. Maybe it's 4. I don't know. All right, so we're going to plug in 3 and negative 3, and didn't really leave a whole lot of space in the absolute value bars there. All right, so over here, this will become 3 plus 1, and that's 4. So that works out. Over here, this absolute value of 3 will also become, of negative 3, will also become 3 plus 1, which is also 4. All right, so that means 3 and negative 3 are solutions. Next. All right, now go ahead and try this one. I know what you're doing. You're pretending that you're trying it. You're not really trying it. All right, so what happens with this one? So we're going to subtract 4 from both sides, right? We're working on isolating the variable here, or the absolute value. We got the absolute value of x is equal to 0. All right, well, let's think about if I were to set up related equation here. 0 is itself, right? It's a negative. We're not, so I can't like set up related equations here. So this means that the only way to get an absolute value equal to 0 is if x itself were 0. All right, so that's an example of having one solution. All right, example 4, we got a lot going on here in terms of having to isolate our expression. What's in the absolute value bars? So first, I'm going to subtract 1. I'll get 4 times the absolute value of 2x minus 3 is equal to 12. Now we have to divide by 4 first before we go setting up any equations. So we're going to have the absolute value of 2x minus 3 is equal to 3. Now I can set up my two related equations. So I'll have 2x minus 3 equals 3. Or I'll have 2x minus 3 equals negative 3. I'll have to solve both of those. Alright, so let's solve this one first. We add 3 to both sides. I get 2x is equal to 6. Divide everything by 2. I get x is equal to 3. Alright, over here, I can add 3 to both sides. But these will cancel, so I'll get 2x is equal to 0. It means that x is equal to 0. And I realized I boxed those up prematurely, right? Because we should always check our work. So we go way back to the beginning here. Using parentheses. This is why we practiced this a few days ago in our intro to absolute value functions. Using parentheses when we're evaluating these expressions. Alright, so I'm plugging 0 here, and I'm plugging in 3. Alright, so over here, this is going to become 4 times the absolute value of 6 minus 3 plus 1. Alright, well 6 minus 3, that's going to be 3. Absolute value of that will be 4 times 3, which is 12 plus 1. Hey, that is 13. That works. Cool. This is going to become 4 times the absolute value of negative 3 plus 1. Trying to see if that's equal to 13. And lo and behold, this is going to become positive 3 times 4, which is, again, 12 plus 1. Gets me that 13. All right. Now for example 5, go ahead and try example 5 on your own first to get started. Actually, take a minute or two. I see you. I know you're trying. You're not pausing the video. Actually pause the video. The joke I always give my students is, I already passed Algebra 1, right? It's your turn. I already got my diploma. Alright, so to isolate this absolute value, we have to divide both sides by negative 2. So I have x plus 1, absolute value of x plus 1 is equal to negative 7. Uh-oh. Can we have the absolute value, which is always positive, equal to negative number? We cannot. So we say no solution. Or you can use this little symbol, the empty set, if your teacher is fine with that as well. All right, last but not least, example 6 here. So we're going to solve this equation. X plus 4 equals 3x. All right, so this is our first one where this is more like, got some v here intersecting with like a line, right? Could look like that, could look a little bit different, right? But the point is that this is not a horizontal line this time. This is a nice linear equation on the right hand side. No, linear expression. Anywho, let's solve. So absolute value expression is isolated, so we can set up our related equations that will look just like before. So I'll have x plus 4 equals 3x. This one will be x plus 4 equals negative 3x. So it still works the same. We're just putting the negative on the right hand side. Now we're going to solve We like to make this a variables on one side as soon as possible. So I'm going to move that x to the other side, divide both sides by 2, and I'll get that 2 as x. And then over here, I'll subtract x from both sides. I'll have 4 is equal to negative 4x. Divide both sides by negative 4. I'll get the x is negative 1. All right. Now I'm going to check my work. So I'm going to plug it back in. Notice right now we're plugging it in on the right hand and the left hand side since there's an x over there as well. All right, so let's go. We're going to have plug in 2 here. Everywhere there's an x. And over here we're going to plug in negative 1. All right, so over here we're going to have the absolute value of 6 is equal to 6, which of course 6 is 6. That's perfect. Over here, negative 1 plus 4, that's going to be the absolute value of 3. We want to know if that's equal to negative 3. Well, this is going to be positive 3 equals negative 3, right? Which is not true. So that means this is our first extraneous solution. And x equals 2 is our only solution. All right, folks, there you have it.